In this video, I want to talk about Pythagorean identities and how they are created and how I can come up with many derivatives of the Pythagorean identities. So we're going to start with a right triangle in the first quadrant. I'm going to label each piece x, y, r standing for radius. Using Pythagorean's theorem, I get x squared plus y squared is equal to r squared. I'm going to manipulate this equation just slightly by dividing every piece by r squared. As a result of that, I get 1, and my equivalencies to x squared over r squared is cosine squared x, because that would be adjacent over hypotenuse, and y squared over r squared is opposite over hypotenuse, which translates to sine squared. So we get this Pythagorean identity, cosine squared x plus sine squared x is equal to 1. And this is our main Pythagorean identity. But all derivatives of the Pythagorean identity can be obtained by manipulating this equation. So let's just take a look. We can come up with a different form just simply by subtracting sine squared x from both sides. We can also subtract cosine squared from both sides. So these are two equivalent statements to the Pythagorean identity. Next, we can come up with other derivatives, again by using manipulations and the golden rule of algebra, so to speak, what we do to one piece. If we do them to all pieces, we have equivalent statements. So we're going to start with our Pythagorean identity, cosine squared x plus sine squared x is equal to 1. And I'm going to divide every player by cosine squared x. That's the golden rule. It's allowable. It gives me an equivalent expression. And now when I simplify this expression, I get 1 plus tangent squared x is equal to secant squared x, because sine over cosine ratio is equal to tangent, and the reciprocal of cosine is secant. In like manner, I can take that same equation and divide everything through by sine squared x. And again, when I simplify each of these ratios, I get 1 plus cotangent squared x is equal to cosecant squared x. Now when I put these two side by side, we can see that there are some similarities here. First of all, if you just memorize the first line, 1 plus tangent squared x is equal to secant squared x, the one right below it, you just add co in front of each of those trig forms. So you get 1 plus cotangent squared x is equal to cosecant squared x. And of course, each of these derivatives can be rewritten as equivalencies. So these could just go on and on. Again, for that first one, we can write that as secant squared x minus 1 is equal to tan squared x. We can say secant squared x minus tan squared x is equal to 1. Again, this is just simply by maneuvering the components around the equation using the golden rule. In like manner for the next derivative, we can come up with other forms. So basically, in a nutshell, folks, whenever you see the presence of your trig function squared with 1s in the equation, you want to test it for a Pythagorean identity. And again, you really only need to memorize the very first Pythagorean identity, cosine squared x plus sine squared x is equal to 1, and then know how to derive the other forms. So that ends this video.